Hey everybody, this is Larry. This is day 3, third day of September. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. I will be doing this all month and maybe beyond. Anyway, today's problem is Erect defense. I usually solve these live, so if it's a little bit slower, awkward, watch it on your own speed. Maybe 2x if you need. But okay, so you're given trees, you find a minimum of fence it. Okay, so this is just exactly what's it called? Convex hull. N is 3000, so you at least in Python probably you cannot do you have to probably do a n square algorithm. Oh, sorry, n square algorithm isn't fast enough, so you can't do something like. I mean, GIF wrapping is technically n squared, though also technically is n times h, where h is the size of the hull. They're also like n log n and n log h algorithms. Divide and conquer. What's it called? There's mono chain algorithms for it. But to be honest, no one is going to. Excuse me, but to be honest, no one is coming up with this in an interview. No one is going to come up with this without already knowing it. So either you know it or you don't, to be frank, both in an interview and maybe even a contest. Though, of course, unless you're on site, you just Google this because this is just silly. But yeah, there are a lot of them. I'm not going to go over it too much because they're literally there are as many convex hull algorithms as there are sorting algorithms pretty much. So, I'm not going to get into that much, especially in a two-dimensional plane of space, because, it's just a very common thing. Like, as often as you do sorting, on a list of numbers, you do a convex hull and computational geometry. Okay, I'm gonna make what do I want to do for this one? Because this is literally a textbook problem, meaning you copy the code from a textbook or something. What I think I'm going to do is that I usually try to remember if I can prove this from first principles, or we do this from first principles. So we'll see. The one that I like to do is called is it monotone chain? I don't remember what it's called exactly. Monotonic chain? I don't know. Monotone chain convex hull algorithm. It's one that actually relates a little bit to what's it called? Monostack or monocube, if you will. The idea is that you calculate the top hull and then the bottom hull at the same time. Let me double check for a second. Okay. So one thing that is sometimes awkward on sometimes, and yeah, it depends on what they ask, because you want the convex hull, so then you want to what is the answer that you want, right? You can either have the points on the parameter, you could get the area, which is a common one, and so forth. This one's also a little bit, you have to be careful, because on the perimeter, 3 points could be collinear, right? And in that case, or even in this case, for example, actually they tell you, in that case, then you have to return sometimes you can, sometimes you don't, depending on the problem. So that's something that I'm thinking of as well. Okay. Okay, let's see. So now we basically calculate the bottom chain, maybe. I mean, it doesn't really matter per se. So yes, let's do it. So we basically sort everything by the x coordinates. So we sort everything by x. So let's just say coordinates for coordinates of 0. So then now we're going from left to right. So I'm scrolling up just because I'm trying to see if I can have a mental visualization. It's been probably at least, when did I learn this? Maybe like 2003, 2004. And then after that, I mostly, if I needed, and even then I probably only needed convex hull maybe like 5 to 10 times ever in competition. So like every couple of years, and every time I mostly already know, or like I have the library that I've written before, right? So I don't have it. So this is gonna be the first time I'm trying to implement it from memory. So we'll see if we learn anything, or if I learn anything, or anything like that, right? But yeah. So okay, let's just have lower, bottom. Do we go lower or upper? Whatever. Let's do a lower, and then now for X, Y in trees, what do we want to do, right? So basically, we're trying to find, from going from left to right, the bottom is both the bottomest. It's not just the bottomest, but a point that allows you to like, there's no point to the right of that point, right? And there are actually a couple of ways to do it. You can draw lines. Let me see if I can pull up Paint Shop over here. The thing that I remember from my day, which I think people don't care as much anymore for whatever reason, is that you can actually do all these with ints. And the way that you do them with int is by doing something called like isLeft, and then isLeft is of course just like a is it the cross product, right? Something like that. But yeah, but basically the idea is that, okay, you have some points on the thing, some points on the plane, and then the idea is that now you're going left to right. And to be honest, right now I'm explaining to myself more than anything. So yeah, so then initially we have this point, and then next point we consider this point. Let me change the colors a little bit. Try to see if I can refresh this. Yeah, yellow is terrible. Hang on. The next one is obviously this point. So then now we tentatively draw a line, right? And this is going to be very similar to like I said, mono stacks algorithm, right? Like a monotonic stack algorithms. Yeah, and you'll maybe see why in a second. And next one we consider is here. Oops. And this one obviously is to the left of it, so that means that it cannot be the bottom. So then we skip it, and then the next one we is here, and then of course this is to the left of the previous line. So then now we erase that line and then draw a new line, right? And then now this is no good. Maybe I should use a different color, right? Same logic here. Oh, I think I messed up a little bit. I think it was too early to say that this one was no good. I think, to be honest, I think technically speaking, sorry, it's been a while. We would draw a line here and consider that as lower hull. But then, of course, now that we're here, we try to draw this here. Of course, that's no good, because if you look at this line, change color again, because this line, straight line please, because this line is to to the thing of this. So then now we pop this one, and then now again we go next, which is that this line is if you think about it from that perspective, you can get lower, right? So then now you get rid of this one as well, and then next one you go here, you basically go here, because now you have or maybe you could just do a cross product where you can clearly see that the triangle has a positive thing. If this has a negative area, maybe if it has a negative area, I mean, I know that negative area is technically not a thing, but in a signed area, maybe if it has a negative area, then you go up, and then so forth. And then, yeah, and then you can eventually wrap around. Oh, I guess I skipped this one. Technically, you wrapped around here, then this gets popped off the stack, and then you get here, here, and here. So, roughly speaking, I mean, okay, fine. You go here, pop off, and goes here, right? So that's the bottom of the chain. And then, of course, you do the same with the top. Let's choose. So then you go this. We'll pretend that this is the top. And then here, going this way is too bad. So then we actually pop off, and we go here and so forth. and then we go here, and then we pop that off to go here, and then we pop that off to go here, and then we pop that off to go here, and then lastly here, and then now you have the top chain and the bottom chain, right? Anyways, a lot of this is established literature, so I know that I'm not doing quite perfect with this per se, but like I said, this is from my memory from when I learned this. Was it 2003, 2002? You do the math how long ago it is, and from here it's all memory. So yeah, okay. So then now let's do the lower first, and then we go from left to right. The tricky thing is that I have to remember how to do the how to check whether we're going left or going to the right. Of course, that's the signed area. I don't remember that formula though. I mean, I do remember that formula, but I forget whether it is signed or not, because it is just the cross product of. So okay, it's just embarrassing how bad I am at geometry. Okay. Okay, well, okay, first of all, if is less than 2, then we just append xy, and then we continue. Otherwise, we get the area of a triangle, right? And then now basically we have ax, ay is equal to 2 points back. Okay, so we do this while length of lower is greater than or equal to 2. Okay, and then bx, by is equal to lower minus 1, and then xy is just the current, but that's just for consistency's sake. For my consistency's sake, because it's been a while. So basically, it is the cross product. Is, I mean, and this we only care about the sign, so I know that is something over 2 to be honest. But yeah, there's also the Yeah, I mean, okay. So it is, how does that go again? Times bx plus bx times cy plus cx times ay, and then technically it's just over 2, I think. Wait, no, I forgot the other path. It's been a long time, so it's well, it's this, but it's minus bx times ay. Yeah, okay, yeah, that way. Yeah, okay, I guess we could do it both ways. It's been too long. But I'm just trying to, so what I'm doing in my head is just doing the diagonal thing in your head. Minus ax times times cy. I think this is right. So I'm like taking a few more minutes to double check, because I'm just doing basically the cross thing for cross product. Okay, okay, that looks okay. I hope I'm okay. It's been a long time. Okay, right, so that's the area. And to be honest, I don't remember whether this should be positive or negative for this one, so we'll just, I guess it doesn't really matter. Either we get the upper or the lower. So, I guess it doesn't really matter, but, okay. Yeah, okay. So, okay, now what do we want to do? We have to double check this, of course, later, but let's just say if area is going to 0, then what? I always forget which way the cross product goes, but anyway, so let's just say if it is, okay, so if this is less than 0, say, then we pop lower. from the stack, and then we continue. Otherwise, we append cy, and then we break. Okay, maybe this is okay. Let's print this out real quick at the end, just to see. Oh, whoops! Time is course. Maybe I'm thinking of the beer. Okay, is this reasonably right? I don't even know. What does this look like? Is this the, well, this is the input. So 1 and then 4, 1. So this is probably, or 4, 2. Is this 1 on top? Yeah, so we're probably going the wrong way. Maybe. Something is just wrong in general. Well, it has 2 numbers because these are the first things that gets popped. I'm thinking about how I should be sorting it correctly. Let's see. This is a little bit awkward now that I think about it, because this could pop, but then now if you pop and it's lower than whatever, then I think I need to put this here, and then we just break early. Okay, let's try again. Okay, this is slightly better, maybe. Oh, the 4-2, I think I confused 2-4 and 4-2. So now we have the lower. I hope this is right. I mean, this is right for this input, I believe. But they're only like 5 points or 6 points, so you can just get lucky. Okay. And this is also a degenerate case where this is a line. So for a line, I might have to handle this a little bit differently. I don't know how. Okay, so this is the lower thing. We can also do it at the same time, do the upper thing. We can do it at the same time, to be honest. But I think it's just a little bit clearer if I do it separately. At least for me. I mean, you know, especially as I'm proving from first principles. But feel free to do whichever way you like. Okay, I'm just going to copy and paste this part, which means that I've done something silly. But okay, if I need to do this again, I'll put in a function. How about that? And then in this case, is if area is greater than 0. I'm trying to think about a case. I think there is a weird case where I'm trying to understand whether I'm parsing these correctly or sorting these correctly. I think, well, I'm actually relatively certain that I'm wrong in the edge cases. Basically, if there are 2 points that are on the same x coordinate, I'm trying to think about if I'm handling them correctly. Okay, let's print it out real quick, and then we have one obvious case is just like a box, which is just say 0 0 1 1 0 1 1 0, right? So if we get the upper bound and lower or upper chain and the lower chain correct on this one, then I'll be very happy. I didn't print it anything, so I don't know what I expected. Okay. So the lower bound is 0 0 1 0. That's true. Upper bound is 0 0 1 1 1 0. Which is technically true, but I think it just doesn't feel too right for me. And you can also think about like a box with 3 on the side, right? That's not going to be correct. So I think I have to handle it a little bit better. And I have to think about how to handle that edge case. So let's also do that case, right? Of 3 by 3, say. So yeah. I haven't implemented this in a while, but it's kind of fun. Did I mess up? No? Okay. Oh, I did mess up. It is kind of fun to kind of be able to prove something from scratch. And I think I'm mostly there, even though maybe not. I mean, I'm mostly there, but the edge cases may be the other 90% of the problem, as they say. Okay. So yeah, so the bottom, I needed to go all the way up. Right? How can I be assured of this? Ideally, so given I don't even need to look at the other ones, but given a 3x3 box, and maybe I could bring back the draw brush. The draw brush? Basically, what I'm trying to think about here, or right now, is that, okay, we have essentially a box, right? And I want to make it so that my chain is consistently everything from here to, oops, everything to up to here, including this one. And then my upper chain could be everything here and including this one. I mean, the overlaps is fine. We can use a set to remove them, but that's what I'm trying to figure out how to make sure that I do. Okay, that's basically what I'm going to struggle with for now. Okay. If there were no collinear points, I think we're actually done, to be honest. Yeah, but there are, so we have to think. We have to handle this a little bit better. There are only 7 points. No, did I mess up? Nope. I think their answers are wrong because there should be 8 on the perimeter. Because there should be 0, 0, 0, 1, 0, 2, and then it goes up, and then 1, 2. Yeah, there's no 1, 2. You know that is on the point unless I messed up. No, it's one here. So I think their answers is wrong too, or they don't handle the collinearity quite correctly. Yeah, maybe I could submit for extra points, but yeah, pretty sure that's right? Or at least like in terms of what I'm saying. Okay. So basically we need each one to have 5 points. What? So 0, 0. Okay. Oh wait, did I do the upper first? No, I do the lower first. I'm sorting by X. So this is not doing, so 1, 0 got eliminated. Let me also just double check that I am right. Let's check every state so that I want to see if 0, 1 or 1, 0 got eliminated along the way. So it seems like, did I mess up the sorting? No. Oh, I see. Because it goes to zeros. The first 2, so it goes here, and then here it goes by the 2. The area is less than 0. Shouldn't be. The area should be exactly 0, right? Let's print that out real quick. Okay, we don't need Yao for now. All right, at least put it in the bottom so that I could look at the one that I care about on top. Yeah, so this is 0, this is 0, 2. And then, so this is what I expect on the bar. Wait, am I messing this up? Which one is X again? X, Y. So maybe I'm just mixing things up, to be honest. Because now you have, because my lower thing is going, I'm just confusing my X's and Y's, to be honest. And this is terrible because they did one that's symmetric. No, that's not true. They have a 2, 1. So this is 1, 2 or 2, 1 or 2, 0. Sorry. So they have a 2, 0. So that means that this is going upward. So this is actually my lower bound is an upper bound. Yikes. We can actually fix that though. Let's see. Let's see what happens here. So then now we go 0. 0, 0, 1, 0, 2, and then now 1, 1. If this is lower bound, this is very wrong. Let's see. Okay, so this is the, so I draw it going up, okay. And then now we do 1, 1, and has a negative sum. Or negative area. As a negative area, did I mess that up? So negative areas to the, if it's 0, we just keep going, that's fine. No, so okay, so maybe I had it right last time. It's just that that's just the nature of things going up. Because if that's the, okay, maybe that makes sense. Okay. Okay, so actually, no. Where did the 1, 0 go? Did I mess up? Why is it 1, 1? Let me print that out. I was just lazy about printing it, but huh. Did I mess one? Oh, I am dumb. Okay. I was wrong about maybe the test case is being wrong. I did mess up on the test case. I put this in, okay. Wow. Yikes. I just put in the wrong input, that's all. Okay. Maybe this is a little bit better now. Maybe this is better now. Okay, so this goes up and then this goes down. Okay. Now I'm way happier. Well, at least this part. Let's see. Let's look at this part. This one just looks awkward though. So I think this is wrong. The lower thing is right, maybe. What did I fix? Okay, so I fixed the lower thing. I think the lower chain is fixed. 2, 0, 2, yeah, okay. And then here, this is just very clearly wrong, maybe. What's 1, 2? Yeah, this is just really weird and wrong. Maybe the way I'm doing it is funky. Let's actually do this the other way, where we go backwards and then we do the same things. So then we're going clockwise. Is it clockwise? I don't know anymore. Okay, let's see. I guess I don't print the intermediate stuff for the upper, but let's see. So we start at the 2, 0. We go to how do I only get part of it wrong? What is happening? Like, how is that possible? Shouldn't they be mostly symmetric? Am I even confident anymore? So we start here. Oh, I see. This is not good enough because we have to also, okay. We actually have to sort. No, that's not true. No, this is good enough. Because this automatically means that in the same thing, the Y gets sorted. Okay, yeah. So we start at 2, 2, that's reasonable. 2, 1 doesn't make sense for an upper hull. In fact, now it's just returning more or less the entire every number on the upper bound. Oh, that's why. Did I copy and paste this? I guess so. I was wondering, like, this doesn't even make sense. Like, it should be wrong consistently. Okay, there we go. 2, 2, 1, 2, 0, 1, 0. Okay. I wonder if my original code would have worked out too. I think it should, but I'm just going to do it for science. Otherwise, but not that much science. If it doesn't work, I'll just go back to what I was doing. Okay, so 0, it goes up, up, and then, okay. This one is the regular square, 0, 1, 0 for the lower. Yeah, I guess that makes sense. Do I still want it to go upper? That would have a positive one. Why doesn't that work? Or why does that not do anything? That's weird. Did I mess something up more? And why does this look like this? Shouldn't it begin at 1, 1? First point should be, oh no, I changed it back, I forgot. Okay, so then now it goes 0, 1, so up and then the corner, but then why does it keep going? Or like it should be, the sorting doesn't make sense here, because did I sort? I sorted it. Oh, I am being silly. Poop. I guess I'm glad I caught this. I think what I meant to write is actually this, well, or it's just something like this. But because I did the worst of both worlds, in which I left it out, it just kind of treat everything as the same. So it wasn't sorting by Y at all. So actually, but because we're sorting by X, Y in the natural order, we can just remove it anyway. Okay, there we go. Silly Larry. And then now we can just put everything in a set, and I think we should be good. And it's showing the overlap in the corners anyway. So yeah. Ooh. Oh, whoops. I meant it's a little bit late in the day. I mean, I know that this video has been half an hour or so, but I hope this is interesting just because, you know, like I said, I don't know ComXO in my heart, but I am able to. Well, okay, let's actually submit before I say that. But he's like conceptually, I've been mostly able. Okay, there we go. Yay! I'm able to prove from first principles how to, you know, how to solve this problem with ComXO. And I would also say that, you know, if you're on my Discord or even in my YouTubes or whatever, one thing that I always advocate is just like don't do memorization, right? Actually learn the principles, and once you learn the principles, you can come, you know, like just a little bit of detail, like observations about each problem, and you're able to kind of rederive everything. For me, for example, like I said, I'm just able to kind of wait. Is my thing blocking? No, just like using a chain. Like I learned it enough the first time to go, okay, just like go back, and then you just keep on, you know, hugging the bottom or whatever, right? So yeah. Anyway, so this is going to be the n log n because it gets dominated by this sort in the beginning. And of course, this is just, you know, using the stack, every number is only processed, or every coordinate is only processed once, well, once in the lower and then once in the upper, so constant number of times each and linear number of time in total. Yeah, that's all I have. I mean, I don't really have much to add because, like I said, this is a very textbooky problem. So like the literature is, you know, a lot. So, so yeah, but few more fun things I would say is that there are a couple of very fun algorithms that are actually faster than this, technically speaking, because this is n log n, no matter how many numbers are in the chain. But there are actually algorithms that are output sensitive algorithms. That means that the fewer your final points are in the chain, which is the output, the number of points in the whole is h, then you can solve it in n log h time. And this is obviously faster than n log n because h has an upper bound of n. So there are a lot of interesting things there if you want to play around and read up on that literature. But that's all I have for this one. You can check it out here, lower, upper, and then I did it this way because I don't know. I think you can actually maybe reason that the first point and the last point should be the same, but I was just lazy. But yeah, that's all I have. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Have a great weekend. Have a great long weekend for y'all that are in Americas or Labor Day. And yeah, enjoy, and I will see you later. Bye-bye.